So the purpose of this video is several things. And so as we look at this, we just need to make sure that we're paying attention to a few kind of tips and tricks to help us put ourselves in a good spot for what we're seeing with this balancing equations. And so we'll notice that on page 10, the difference between what we have been looking at and what we are looking at is we need to make sure that we first write out the equation. So we have it in word form, but we need to actually write the equation, and then we can go ahead and balance the equation. So there's one step we need to do before all of these others. And so we're going to look at 21 and 24. We'll make some adaptations as we go about to make sure we can hit all the points that I want to for this. So in this first one, number 21, we're looking at iron, hydrochloric acid as the reactants that turns into, we see bonds breaking and bonds forming. This is a chemical reaction, and the products we get is iron, 3-chloride, and hydrogen. And so as we look at this, we can go ahead and write it out. Iron is Fe. And when we get to hydrogen, we'll talk about why we write Fe as just Fe. Hydrochloric acid is HCl. And then we get to two important aspects that we have been talking about. First one is iron chloride, iron 3-chloride, and we know that this is an ionic formula, and so we have to keep in mind that 3, the Roman numeral 3, represents the charge of that iron. So we have a +3 charged iron. Chlorine would be a -1, and then hydrogen, since it's an element, we do not need to worry about the charge on that. It's actually, hydrogen is covalently bonded here, and so we're not going to worry about it, but we'll talk about that in a second. So as we're writing the equation first, the formula, we need to make sure that we balance out our charges. And so we actually need 3 chlorines to balance that out. And then the thing that I want to remind us of, to make mention of, is that when we're dealing with this hydrogen, on the back of our periodic table, we have several elements, and we can look at them as Hankel-Briff. The reason why we need to focus on these is every time we're writing any of these individual elements, we're going to see that we automatically put a 2. These are called diatomic. Elements. And so anytime you see hydrogen, like we do in this problem, we have to write it as H2. If we were to see the same thing with oxygen or nitrogen or chlorine or bromine or iodine or fluorine, we would have to write them as H2O2N2 respectively. So this is our friend Hankel-Briff. We do also have polyatomic elements, and these ones behave the same way. When we see phosphorus, when we see sulfur, we're going to write them as this. So every time we see that, we just need to make mention, or we just need to take notice of that. And so in this case, we're given a hydrogen, so we have to write it as H2. So now we can go through and balance out the equation now that we have that equation written. And we just have to make sure that as we're going through, we're showing conservation of matter by putting these coefficients in. The subscripts can only go in. We can only put those when we're first writing the equation, and now that our equation is written, the only thing we can change are these coefficients. So the first thing I'm going to change is just the fact that we have chlorines and our hydrogens right now are not balanced. And so I know that I'm going to have to erase it just knowing the outcome of this. And so we're just gonna see this happen. I'm going to balance the chlorines first. And so what that does is this gives us 3 chlorines each, but we also notice that we have 3 hydrogens on the reactant side and 2 on the product side. And since this hydrogen can never become an odd number, no matter what we do, we have to make sure that any hydrogen on the reactant side, so reactants, products, on the reactant side, any hydrogen is written with an even number. And so we actually have to get rid of that 3, and the only way to really deal with this is by doubling that number. And so in doubling that number, we have 6 chlorines, so we can easily fix the problem with the chlorines being unbalanced. We now know that we messed up our irons, so I'm going to go ahead and put a 2 in front of that iron. Our irons are now balanced, and now the last thing is the hydrogen, and so we just put a 3 there to balance it out. So as we're going, we're looking at the fact that we have diatomic and polyatomic elements, and so we need to make sure that we account for that, that we have an ionic bond going on with this iron 3 chloride. So we have to account for the charges, balance the charge first and make sure that's neutral, and then also making those odd numbers even for hydrogen, and that's going to make our lives quite a bit easier. All right, so that's the first example. The second example that I want to touch on is this written one down here. It's a little bit different even from that, but I'm actually going to change this name. So I know it says hydrogen peroxide, but another way to write this is by writing dihydrogen dioxide. All right, that's the formula name for that. And the reason why I want to do this is because I really want to push the fact that we see covalent bonding is not about the charges, which I think some of us may fall into the habit of looking at, but it's also looking at, well, really only looking at those prefixes. So when we're writing this dihydrogen dioxide, we get H2O2. So this problem says the decomposition of dihydrogen dioxide forms oxygen gas and water. Now, if you'll notice, the problem that we have is we see, if we look back up here, that oxygen is actually a diatomic element. And so when we write in that oxygen, we need to make sure we put that 2 in there. All right. So we have our formula written, so now we can go ahead and balance. As a reminder, we want to make odd numbers even. So on the reactant side over here, we can never see this oxygen be odd. On this side, however, in the water, that right there, that oxygen in the water is making the product side have an odd amount of oxygen. So right away, I'm just going to make it even by putting a 2. I'm going to do that before really even looking at anything else, before looking at numbers. I know I have to make that odd number of oxygens even, and so now we can go from here. So we can see we have 4 oxygens on the product side. We have 2 oxygen on the reactant side. We're only dealing with hydrogen and oxygen, so we don't really care which one goes first. So to balance that out, I'm going to go ahead and put a 2 in front of our reactants. We can see we have 4 hydrogen and 4 hydrogen on the reactants and product side, so we can see that we have this balanced. So again, as a reminder, we're looking at diatomic, polyatomic elements. We're trying to write the equation first. After we've written the equation, then we can go through and balance it. But in writing the equation, we have to make sure for ionic substances we balance the charge. For covalent substances, we look at the prefixes, and we cannot forget about our acids, as we learned how to write them a little bit ago. So hopefully this helps and makes things a little bit more clear.